All right, so more food web analysis and energy pyramids. This is the assignment I gave you on February 12th. That was that Friday before we went on the long weekend, which turned into a whole week. You guys know what happened on that. But I had the sub that day. Hopefully you filled it all in, but I wanted to go over it now because I think it's important that you guys check your answers on this and know that you did it correctly because our test is this week. So these pictures I gave you on this slide, I put them there for a reason because that's a preview of a couple of the things you'll see on the test. And I mentioned that on Notebook Update, but this says a change in the size of one population in an ecosystem will affect other populations, and that's usually true in any ecosystem and any food web. And it says, for example, when there are too many giraffes, there will be insufficient trees and shrubs for all of them to eat. In other words, there's going to be not enough trees. If you have too many giraffes, they're eating too much. There's not going to be enough for some of them, right? So many giraffes are going to starve and die. Fewer giraffes means more time for the trees and shrubs to grow to maturity and multiply. So then your population of giraffes goes down, and then your tree population kind of goes up because of that. So fewer giraffes also means less food is available for lions to eat, and some lions will starve to death. So because the giraffe population goes down, then the lion population also tends to go down. And when there are fewer lions, the giraffe population increases again. So then that causes an upward tick in the population of giraffes because there's less pressure on them from the lions. And I gave you some discussion questions on this. Said what organism's population would most likely grow if you remove the lion? So the lion I see has 5 arrows pointing to it, which means it eats 5 things in this food web, and you pretty much just have to go by that, which population. So directly, the zebra, the baboon, the antelope, giraffe, and cheetah, because those are the things that it eats. Indirectly, what's going to grow, I put hyena and leopard because now you have two organisms that are competing with the lion for antelope. And because the lion's not there, there's going to be maybe more antelope. The lion's not eating those 2 animals, although it would if it got a chance. It's just not in this food web. But there's going to be less pressure on the antelope, and that's one of the things that the lion shares with the leopard and the hyena. And in fact, the hyena also shares the zebra. So because there's less lions, there's going to be more prey that they're usually going to be preying on. Right? What organism's population would most likely grow if you remove the baboons? So again, I have this kind of a direct effect and an indirect effect. So what are the baboons eating? It's termites and it's grasses. And so those two for sure, right? Directly, the termites and the grasses. If you look at it indirectly, if there's less pressure on the grass, the zebra and the antelope are benefiting from that. Right? So there you go. The next one said, what would happen to the number of shrubs and acacia trees if the baboons were removed? And explain your answer. So if we're removing the baboon, it's not eating the acacia trees and shrubs. However, it's eating the thing that's eating the acacia trees and shrubs, and that is the termites, right? So their populations will probably decrease because the baboons will not be eating the termites. The termites will be putting more pressure on the acacia trees and shrubs. Because the baboons aren't keeping the termite population in check, there's more termites than there normally would be. Then there's going to be more pressure on that acacia trees and shrubs, and really on the grasses too. But it didn't ask about the grasses. Then it says, explain how the leopard would have to adapt if the antelope population declined. So you got to look at this from a couple of different ways. That leopard, that big carnivore there, which in this food web, it only shows that it's eating the antelope. And they are pretty selective about what they eat. It can't be something too big. They like to actually drag their kill into a tree, and they're extremely strong, powerful animals to be able to do that, because a lot of times the antelope weighs more than they do. They still get it up into the tree. That's a way that they can have their prey, and something like the lion or the cheetah or the hyena or any of those other animals aren't going to be able to get it if it's up in the tree. Those other animals aren't great at climbing. The leopard is. So the leopard's a big cat. It can fend for itself pretty well. It's a great ambush predator, and it feeds on a lot of different antelope species, and that's just in general antelope, right? But it's not going to just sit around and starve to death. They are too intelligent of an animal for that. They're going to figure out one of two things. The first thing would be, we're going to start to try to eat something different. And no, you can't say, well, now they can maybe eat grass or something like that. It cannot become an herbivore. That's not going to happen. It's going to adapt. Maybe it starts to eat a baboon. And in reality, leopards probably do eat baboons. Maybe it'll feed on some smaller zebra. They usually don't tend to go for those, or leopard or giraffes. They're a little bit too big for them, but maybe they go for younger ones. But they would look for something else that they could eat. If that's not working out, there's one other option. And they're not just going to die. They're not going to sit around and starve to death. They're going to leave the area. They're going to get out of there. They're going to go to a place where there's more antelope or something else that they think they can eat. They are too intelligent to stay and starve to death. So you got to realize that about those big carnivores. They have some smarts. They are not just a big dumb animal. There's some thinking going on there. And they are not just going to sit around and starve. All right. Place the organisms in the correct columns in the table below. You may have repeats. All right. Not the first one, though. There's only two producers. That's the acacia trees and shrubs and the grasses. The primary consumers, those things that were eating the acacia trees, shrubs, and grasses: termites, baboon, antelope, giraffe, and the zebra. Those are the 5 organisms you should have in that column. Secondary consumers, those things that are eating those primary consumers, right? So the cheetah, which eats the antelope, that leopard, which also eats the antelope, the lion, which eats several of those primary consumers, the hyena, which eats a couple of them, and then you got to include that baboon, because it plays 2 roles, doesn't it? It's an omnivore, so it's eating producers and it's also eating the termites. So that one has to be included on there too. There's only one tertiary consumer, and that's that one arrow going from the cheetah to the lion makes it a tertiary. So there you go. They don't eat cheetah very often, but they will, if they get their opportunity, they will kill one. The thing, and I think I've mentioned this before in class, is that the cheetah makes that kill after running 60 to 70 miles an hour for 400 or 500 yards. It's exhausted. It can't defend its kill. And the lion sees what happened. It can just jog on up there, and the cheetah has to get out of there. It's got to give up its kill. It's not going to give up its life. Occasionally, maybe they're a little too exhausted to get out of the way in time. Maybe there's more than one lion, and a cheetah might fall prey to a lion. It's not going to be all the time, but it probably happens more often than what we think. All right. This one says, use the 4 trophic level food chain to fill in the energy pyramid. Label the trophic level with the organism and correct role for the energy pyramid. Imagine that the producer starts with 3,500 kilocalories. Fill in the amount that would be available at each level. Remember, only 10% gets passed on from one level to the next. So I started you with 3,500 kilocalories. That's the producer level, right? That's that first trophic level. That's the grasses. So that's the producer, and grasses are what you needed to put in there. So then at the second trophic level, you've got that primary consumer. In this case, it's the termite. We're starting that 350 kilocalories there now with the termite, right? We've lost 90% of that original energy from the producer. Only 10% gets passed on, so that's 350 kcals. It's a primary consumer, and it's the termite. That's what you should have filled in there. We move that imaginary decimal over one again. Now we're at 35 kilocalories. right? This is the third trophic level, but it's the secondary consumer. And in this case, it's the baboon. And then at that top level, we're at 3.5 kilocalories of energy. Not very much. Not very much for that lion. It's got to eat a lot. It's got to eat a lot of those baboons to get the energy it needs. Its pride has to consume a lot to get the energy they need. So it's the tertiary consumer, and of course it's the lion. All right, and then finally I had these questions for you with this energy pyramid and that food chain up there, which started with the clover, to the caterpillar, to the frog, to the snake, and then finally the hawk. How much energy is available at the trophic level with the caterpillar? That's the primary consumer. It's eating the clover. If only 10% of that 5,500 kilocalories goes to the caterpillar, then we're looking at 550 kilocalories of energy. What's the role of the caterpillar in the food chain? It is the primary consumer. Right? How much energy is available at the trophic level with the frog? Well, if it's 550 kilocalories at the caterpillar at that second trophic level, then that third trophic level where the frog is, it's only going to be 55 kilocalories of energy. What is the role of the snake in the food chain? That snake is a tertiary consumer. It's at the fourth trophic level, but it's the third consumer, right? Tertiary consumer. And then it says how much energy is available at the trophic level with the hawk. So if we were at 55 kcals at the third trophic level with a frog, at the fourth trophic level with the snake, we were at 5.5 kilocalories of energy. And so what gets passed up to the hawk is only 0.55 kilocalories of energy. That hawk has to consume a lot of snakes to get the energy that it needs. 0.55 kilocalories of energy. All right, guys, hopefully you got all those correct. If you did not, make sure you correct those. And then make sure this goes in the notebook.